So I'm back today to show you a demonstration that I do with my students. It's a multiple step demonstration that we do regarding deposition. Now with deposition, there is a number of factors that go into why certain particles sink the way they do or get deposited the way they do. And that's what I want to show you today. I want to show you all the different characteristics that we have. So the first example that I have is going to be the same material, but just different sizes. I have a small bead and I have a big bead, and they're both made of plastic. Let me show you just a quick demonstration about sheer sizes between them. So there's the little bead, there's the big bead. So I think just by looking at the sheer size, I think you'll have an understanding about which one's going to deposit the fastest. But I want to show you exactly how this is going to go. So the first little bead, I got my stopwatch here. Sometimes these get stuck because of surface tension at the top. So I'm not going to get started until that bead hits the water and will sink all the way down. So let's see how things go. Okay. This bead's right here. Taking sweet time on the way down. Okay, so that's taken about 12.35 seconds. So I'll put that on the board. So 12.35 seconds for the small plastic bead. Let's do large plastic bead. So clear that out. Large plastic bead. Takes about 3.13 seconds. So I think just by looking at those characteristics, you can tell that the small plastic bead takes much, much longer, so this is going to be slower. That's going to be a slow deposition, while the big plastic bead is going to be a fast deposition. Now what I'm showing you here is the difference between time and rate. Time is just how long something takes to happen. Slow and fast, that's rate. That's how quickly or how slowly something takes to happen. So something that takes a little bit of time is going to travel the fastest. Something that takes the least amount of time is going to travel the slowest. Same material, just different sizes. Let's move on to our next station. Next station that we have is going to be a large plastic bead and a large glass marble. So different material, just similar sizes. They're not identical, but they're similar sizes. A big plastic bead and a big glass marble. So let me show you the differences in their sizes. They're relatively the same size, not quite, but that's the closest I could get. I'm going to do the time for the big marble. Oh, I'm sorry, the big bead. And again, very similar to what we had before, 3.43 seconds. So get this up here, 3.43 seconds. Now we're going to do the big glass marble. This goes really, really quick because we're just dealing with very, very different material and different densities. I got 1.28 seconds. So again, let me just show you, even without the stopwatch, that glass marble is going to travel through very, very quickly. 1.28 seconds. So when you talk about the differences in material, you have different densities. So with the big plastic bead and the big glass marble, clearly this is going to be slower in terms of rate, and this is going to be faster in terms of rate. Less time is fast, more time is slow. So we've done two characteristics. We've done different sizes, we've done different densities. Now let's do the same material but different shapes. On this one, I have same material, but we have different shapes. We have a copper BB and we have a copper penny, just one is round, one is flat. So just kind of show you the copper BB. It's actually zinc covered, but kind of see what the BB looks like. And my pennies are a little bit of a rough shape, but those are my pennies. I'm gonna put the copper BB in. Again, this one might be a little hard to see because they're kind of quite tiny, but they go really quick. Ready, set, go. Okay, literally 0.38 seconds. Do it one more time to show you. 0.53 seconds. So let's go with the first one, 0.38. The copper BB was 0.38 seconds. Now, same material. Let's see if shape is going to have a little bit of an issue in terms of deposition. Watch what happens. Actually, let me do this first before I time it. Watch what happens with the penny. See how it flutters down? Now I'm dropping it in flat. Kind of flutters down. Let me drop it in straight up and down. Still flutters down. Let's get a time on this one. 2.21 seconds. So shape definitely has an impact. 2.21 seconds. So you end up having 0.38 seconds. The round is much more aerodynamic, while the flat has a lot more surface area in terms of its resistance against the water. So those flat sides really push against it. 2.21 seconds. Fast, slow. So let's kind of recap here. So we have different shapes. So the round is fast and the copper penny, the flat penny, is slow. We have different densities, different material, different densities. Okay, the low density is going to be slow. The high density is going to be fast. And we also have different sizes. The small is going to travel slow, while the big is going to travel fast. I have a fourth setup here that I would like to do. And this is all relatively the same size sediment, except different material. So the same size, same shape, different material. So I have the little plastic bead. I have a little glass marble. And I have a copper BB. So I have essentially, I have the same size and the same shape, but I have just different materials. So I have a light plastic, I have kind of a medium glass, and I have a heavy copper. So essentially we're going to be measuring differences in density here. I'm going to try the little plastic bead. Try that one first. Hopefully it doesn't get stuck at the surface. It's really taking some time. Bead's right there. Really taking some time there. These tubes are all just filled with water, just tap water, all at the same temperature. It's really slow going, so that must be a little bit of a different plastic from what I used a little earlier. So I am at about 44.09 seconds. Let's try the medium glass. One of these little glass beads. Drop it in. I got 1.68. Try that one more time. Probably a little hard to see. 1.81. So So right, just a shade under 2 seconds to go down, say 1.81 seconds. And then we got the copper. I got 0.59 seconds. Do it one more time. Straight down, 0.53 seconds. Very, very quick. So again, we're talking about 0.53 seconds. So clearly you can see the slowest was the plastic, and it went to the fastest with the heavy copper. So same size, same shape, just different materials, different densities. You see that there are clearly some factors that go into how sediments get deposited and the factors that go into them. So hopefully this was something that was beneficial for watching. Hopefully it gives you some ideas in class. And by all means, students, if you're having some issues with this, please watch this again. Hopefully it will help you in terms of your depositional characteristics. We'll see you soon.